All right, ladies and gentlemen, hello and welcome back once again for the second installment of our new webinar series, How Data Works by Hortonworks. My name is Eric Cavanaugh. I'll be your moderator for today's event entitled Sky's the Limit, Architecting an Enterprise Data Fabric. I can tell you this is a very hot topic as gauged by the activity that we saw from our marketing campaigns. Folks like this idea. I love this idea. I think it's an idea whose time has come. Our speakers today are Scott Clinton from Hortonworks. We also have Dr. Jeffrey Malofsky, old friend of mine and our resident data scientist these days, and then, of course, yours truly. You can always ping me with the chat window or the Q&A to send your questions in, and please do that. That's the best way to get custom value from these webinars. So just the other day, I heard this concept from Dr. Malofsky of welded data. I think it's a fantastic term to use to really describe how things used to be done back in the day. Quite some time ago, we would have applications really have the data coded into them, access to the data coded in, like actual data bytes, if you will, baked right into the application. Well, that's kind of problematic. It's good in that it's fast. That's one nice thing about it. It's going to work very, very quickly for you. But it's not so good in that it's not very agile at all. So you have to watch out for that. And it's in a lot of these older systems, right? So one of the challenges of a data fabric, quite frankly, is that there is a lot of legacy application out there. There's a lot of legacy data out there. And anyone who has been involved in the enterprise software world on the client side using these technologies knows that rip and replace is just a nightmare. It's probably not going to happen. It does sometimes take place, but you have to be very careful about that. And it's also hard just to understand what's going on in there. So this is one of the real challenges with modern data is how do you deal with some of these old systems? How do you integrate them into newer environments? So that was the early days. Then along came this guy, Dr. Michael Stonebraker, and several others, of course. You can look him up on Wikipedia. But he is really viewed as the godfather of the modern database. And he's designed Postgres way back in a past life. And he had read a paper all about this kind of technology and built a database, actually went to the military to try to get funding for it. Couldn't, got shot down, but did get some funding and has since spawned, I think, half a dozen companies maybe. Well, way back in 2005, I actually did an interview for him when I was working at the Data Warehousing Institute, not really knowing who he was, and he was working for Vertica at the time, which of course is a column store, and his whole mantra was one size does not fit all. And what he was talking about is that relational database technology was used in just about every use case where a database was needed. And his point was that's not really optimal. Relational databases are very good at certain things, transactional systems, certainly some kinds of analysis, but really column stores are much better for heavy-duty analysis of very large data sets. And that's true for a couple different reasons, one of which is just compression. When you have a columnar database, typically all the data in a particular column is of the same type, which means it can be compressed much more easily than otherwise. So that was one of the issues. But his point really was that there are so many of these new interesting use cases out there that we cannot rely on one kind of database. Well, after that, my goodness, there was an explosion of database types. We had that whole movement of database appliances. You remember Netezza, of course, later bought by IBM for over $1 billion, which blew my mind. You also had Datopia. You had Datalegro that got bought by Microsoft and has now been woven into their Azure MPP. I'm told it's fading a bit, quite frankly. But the point is you had all of these new database technologies spin out. Now we have graph databases everywhere, lots of very interesting things coming along. And it's important to remember we are now in the heat of the information economy. And what do you need at the foundation of the information economy? You need some kind of database or some kind of data repository. And of course the topic for today is the data fabric. So for many years, for 20-odd years basically, or 30 years even more, these different kinds of database models were running businesses. They're still out there today, still running transactional systems, analytical systems, they're all over the place. But things are changing. So what happened? Well, then the cloud really formed. We had the Apache Web Server, Apache Hadoop, we have Kubernetes come along. All these different movements have really changed how programming gets done. And one of the reasons is just because of the size. If you think of the scale of cloud computing, it is so massive. That's why companies like Yahoo and Facebook and Google and LinkedIn have all created their own technologies because off-the-shelf technologies would not cut it, would just not get the job done. Things kind of changed over the last 10 years as a lot of people realized that Hadoop required a whole lot of reverse engineering. But now what we're seeing unfold here is this concept of a data fabric. And companies like Hortonworks are right at the epicenter of making that transformation, of really building out what is going to become the underpinning layer for the information economy. So one of the challenges is that, I have to tell you, just trying to track the open source industry itself, the open source movement, is bewildering. There is so much stuff going on these days. That's why you have companies like Hortonworks curating these projects, hardening the projects that make sense to them, and then supporting those projects. So you're going to hear about several of those today. Ranger, for example. You're going to hear about Hortonworks Data Plane. These different projects and technologies and platforms really are designed to be the infrastructure to enable this next generation of applications. And just think about all the different kinds of applications that we have, all the different mobile apps out there. I heard a fun story at Strata just last week about how at a large bank, a U.S. bank, the team decided to build a mobile app, but they didn't really think through the amount of pressure that was going to put on their systems, and it wound up blowing things up. Like the day that they launched this thing, it gave them all kinds of problems. So there are going to be unforeseen issues to come across, and they're going to have to do with workload and just being able to manage the throughput of all the data and all the requests, all the information flying around. I think the bottom line is you're going to have to, if you are a certain size of organization or have a certain velocity and variety of data, you're going to have to adopt some type of data fabric architecture if you're going to survive. So once again, going back in time, it was way, way back in 2001 when I first heard the concept of an enterprise backplane. That's what Michael Haston, the consultant then at Damon Consulting, referred to, and that's what he was talking about. So nearly 20 years ago, we had the idea to do this kind of thing. But the difference was back then, we didn't have the raw power of the open source movement. We didn't have companies like Hortonworks focused specifically on curating and hardening these technologies for enterprise use. We didn't have the benefit of 20 years of experience working in distributed computing and data at scale. We didn't have all those things. We have those things today, and that's why the world is changing, and it's changing dramatically, and it's changing very, very quickly. So with that, I'm going to hand the keys over to my good friend, Dr. Jeffrey Molosky, so we can talk a bit about hybrid data clouds and some technical concepts. So, Jeff, take it away.
All right, well, thank you very much, and I'm just going to get a handle on here about the changing the slides. So what I wanted to start out about, let me see if this works. There we go. So you should be seeing the first slide, which talks about clouds and on-premises. And what the real focus is here is the plurality of both. And that's one of the things when I looked over the Hortonworks briefing today, I really applauded. There's, as Eric alluded to, there's been many things that have come across as how to architect on, outsourcing or on your own organization. And what was called a hybrid architecture in maybe 10 or 15 years ago was something about let's mix and match a little bit. But really right now it's a combination of multiple factors, and the opportunity is really there for you to exploit and take advantage of that. But with that, one of the really good things that was shown was multiple clouds. So a lot of times when the discussion, particularly in large organizations, centers on should we go to the cloud, we will go to the cloud, let's pick a cloud vendor, then that really is hampering you and limiting you to what you want to do. And that also changes the type of technology footprint that you need if you're going to cement it. And like all offerings, then if you go to a particular cloud offering, you're going to be channeled into the way that they decided to set up the technology. And even if they give you a one-button way to deploy distribution, there's a cost function for how it actually executes. And so you're going to get channeled into that. And then as you're in a large organization, you're going to have many different use cases that you have to support. So this opens up the opportunity for you to really craft something that works well for your use cases. But to do that means you need to actually sit down and decide what are those critical factors that are going to influence that decision. And so some of them are here in that it's the data and application architectures that you already have. What can you migrate? What should you migrate? There are multiple different security concerns, and those different security concerns have to get mapped onto the different use cases that you're looking at. There's risk mitigation issues, and there's different ways of approaching that. And then there's the fundamental cost that goes into making a change. So even though going to a new approach might reduce your total cost of ownership and your operating cost greatly, you're going to invest something to get there. And the question is, some of those costs you will know, they'll be obvious, and this point will be made by Hortonworks later, and some of those are very hidden costs that generally get not the visibility that's truly needed. And what we're really looking for doing here is to consolidate and achieve operational efficiency. But that has to be done with an understanding of what the relative trade-offs are as you go from your cost function to your risk, and then to the desire to reduce the technology footprint or the distribution of technology. The next part that gets brought up with that is that consolidating data is always challenging. It has always been much harder than agencies, people, groups, teams think it's going to be when they start their journey. So Eric showed you about the welded data concept. We came up with that recently, talking about a Hadoop environment where the natural forces, it's almost like a gravitational wave. So the more that committees meet, the more they look for that common denominator that everyone can understand. And that common denominator is almost always hard-coded. You know, you hard-code a SQL script. You hard-code a transform script. And that really locks you in, and that gives you the welded data. So even if your project is ostensibly to solve the problem of prior silos, if you repeat the methodology that led to those prior silos, you are simply recreating a new set of silos. So you have to really keep that in mind, and that is very difficult. That brings up the issues which can be globally talked about as aggregating and normalizing data, and then as lots of people will tell you often, your organizational issues will dominate your technical issues. So on the next slide, it gets into really what we're talking about. So we're talking about the scaling here, because we're talking about big data technology. You go to the cloud. If you only had 5 megabytes of data and you needed to run a report once a week, let's face it, you don't really need to go to the cloud. You don't need big data technology. So really what we're focused on here are those additional issues that arise because of scaling. And then scaling takes on a life of its own. Just like going back to the beginning of computers, the rule of thumb was if you have hard disk capacity, you will fill it. So the idea was always get as much hard disk capacity as you possibly can afford whenever you purchase a server or a desktop computer. Well, the same thing is happening in these big data environments. As you start out with some data and then it looks like, oh my goodness, look at all the space we have. Well, one, they all replicate. They have a replication factor. That's what the HDFS does. So that could be 2 or 3 or 4 or whatever. So you multiply that. And then you're going to find that you can do so much more analysis and so much more processing that you're going to end up starting to fill that up quickly. The good news is the cloud particularly has already been built with all that in mind, with big data. And that's both critically in the support infrastructure. These are still servers. You know, just because we call it big data, it's still a server. That server has CPUs. That server has power supplies. That server has hard disks and RAM disks and all this stuff. And all those things work or don't work and crash and burn at various times. And the big data technology is great, and one of the reasons you reach out to a well-established distribution is that I've actually spent a great deal of my time in the source code of the Hadoop stack because I actually run full-blown production systems doing heavy-duty analysis, and things happen. And they happen, and trying to find the root cause is non-trivial, and I generally have to go to the source code because the documentation isn't always up to date with what the code is doing. And then it's like, okay, now I got it, and now I can back out. So one of the things you get from the cloud is you get that infrastructure support. But you also want that out of the distribution that you use. So the distribution will actually solve some of those problems, or very, very beneficially be prepared to show you some information about that. The other part that you have to do with this is that tackle, and the word tackle was there on purpose, long-standing challenges with disjointed data sets. That's where elements have the same names that mean something completely different. They have different value sets in different systems. You have to bring them together and decide, are you going to push them together? Are they truly different? What do you do about that? What do you do about frequent schema changes that come from one part of your organization and not another part? And then we'll show you some of that in the next slide. But the other part of this is realizing that your costs will increase before, as I mentioned before you reap this lower cost and efficiency. The next big issue to focus on is your risks, and there's multiple facets of risk. One is that as you scale up, that you will then have the possibility, it may seem counterintuitive, that your outcomes will be of lesser quality. And that actually is tied to those prior issues about tackling those long-standing challenges. If you now incompletely articulate how the schemas come together and the values come together, you're going to be generating analytic outputs and application outputs that could actually be worse off than what you had before. And then that'll feed back into your organization. Obviously, we're paying attention to breaches, and one of the other things that will be pointed out by Hortonworks shortly is how you can address that and what that means. And then there's a cost function to doing that. In fact, interestingly, I know personally about some of the work that is post-breach, and it's some of it is being done by AI algorithms, but the bulk of it actually shows up in the hands of lawyers, with lawyers sending you expensive bills, and those lawyers are hiring other people to manually go through all the documents that might have been breached. So think about what that means. And they're manually reading those documents, and they're coming up with manual legal arguments of what your risk exposure is. So in the next slide is a graphic that I show often because it came from a friend of mine in a large organization. And all I'm really introducing here is this is the real world. This is the real world in almost every single large organization data system. So when I use that verb tackle before, this is what you have to tackle. Now, the really great news is, and this is why I really applaud the approach of the hybrid design, is you can now choose which of these you want to solve and which of these you want to ignore. And that's a really good news story, because in prior approaches to doing consolidation, it was solve them all. You know, let's build a semantic layer, and that semantic layer will map all the variations in everything we do. Well, that fell prey to all this, and the fact was that the human beings in the organization couldn't figure it out. They could not come up with a common semantic basis of all the variable use cases, so couldn't work. So now with this hybrid approach, you really can pick and choose. You can say, you know what, we're not going to do any of the left side, the orange, we're just going to do the others, and off you go. And so that's actually, I think, a really good approach. And then finally, it's the design criteria. So it breaks down into some common sense items here, is just decide what you want to do on the cloud. Some of it might be you must do this because the growth of your processing and storage exceeds what you can do in any individual approach. There might be some things you want to do for risk mitigation, and that is to lock in a particular one cloud, so you spread it out. That could be the cost benefits that one cloud provider or one on-premise data center provides you efficiency and cost with one use case, but not so for a different use case, so then you move that somewhere else. You may not be able to do some of these things now because it seems too excessive because you can't solve some of those aggregation problems. So you're going to have to wait until you can do so. And then some is to take that risk very seriously. Like everything else in business and life, you may have to say, this is a really great idea, but our risk exposure is too high. Now, I've seen some large organizations where that decision will be made by a combination of the chief risk officer and the chief financial officer. So it would behoove you, as you come up with these plans, to think about whether or not they're going to be doing a review on that. And then since we're talking about hybrid, you can also do some things on premises, all the same criteria, and then how much do you want to centralize. And be aware there that there's usually a very high pain function to centralizing data centers for a whole bunch of reasons. And then finally, and then I'll hand this back to Eric, is be flexible. One of the benefits of a hybrid design is if you truly start with the objective of flexibility in mind and some sort of frequency of change, you will be well ahead of your game. So write down the lessons learned, not just your organization, but there's a lot of lessons learned that are freely available out there in the world. And the same thing with how costs go up and down and how you might redistribute over time, not just across different cloud providers, but go back and forth between on-premise and cloud. And I particularly have seen that over the last 10 years in some of the financial institutions where they outsourced everything and then they fired those people that brought it all back in-house, and then they took a chunk of it and sent it back out again and bouncing back and forth. Well, that's actually now a lot easier with this hybrid approach. So with that, I'll hand it on back to Eric.
All right. Okay, hold on. So let me hand off the keys to Scott Clinton of Hortonworks. He's going to share his screen. And folks, I will post a link to the slides here in just a second. And Scott, the floor is now yours. Take it away. Scott, are you there?
Yeah, thanks, Eric and Jeffrey, for setting the stage. That's great. Let me go ahead and get my slides shared here, and we'll go ahead and get started. I think as we talked about, both of you mentioned, the idea around a data fabric is not a new idea. Historically, we've had the support for, looking at it from a data backplane, data fabric. What's new is certainly what's new is the architecture in which we're deploying this and the technologies in which we're using, and again, the scale at which we're working at with big data. When we start looking at some of the things that are changing this, obviously cloud is a key component of that. Data architectures are increasingly becoming and involving cloud architectures. These are being commingled. In many cases, cloud architecture started first. The mandate for doing cloud has come to IT organizations some time ago, and a lot of times those approaches didn't necessarily take into account the data architecture. So a little bit about data getting left behind. So as we look at today, as we're evolving architectures, we've got, based on some recent studies, we've got 70% of companies by 2020 will have 50% or more of their data in the cloud. And that just won't be one cloud, that will be multiple clouds, because even today, most companies have almost 5 clouds that they know of. So multi-cloud actually started before hybrid cloud started. If you think about it, the whole focus around new workloads and new SaaS solutions in the cloud, all these great new data analytics tools and solutions are actually being purchased by lines of business. They're creating new silos of data. So all this time we've been focused on our internal IT kind of getting control over the data silos and placing governance over those. Now we have this whole new area of expansion around new data silos in the cloud. Well, at the same time, we're having to ensure that this data gets incorporated, and it is integral, and it is managed. So this creates a lot of pressure on the organization as we're talking about, both in terms of the ideas around costs and operations. In fact, you can see that in a lot of the early work that's been done in people going to the cloud. So it's very clear that, you know, the public cloud isn't for all workloads. We've got, at a recent survey from IDC, they've got 80% of decision makers have migrated applications and data back from public cloud. They've looked in, you know, when you look at what are the workloads you should be considering, costs are a big piece of this, both costs, security, how are you going to govern it, and as a result, finding a way to do this in a scalable way is a challenge. So a lot of organizations, as I think Jeffrey was saying, are doing it by hand in a lot of ways, managing your policies, managing your data, moving things back and forward, which can be done, but is you know, challenging. The other aspect, of course, is the cost. So if you look at costs around these, why are these people moving these workloads? Certainly, it's security, it's governance, it's the things that we usually are considered around in the cloud. It's also vendor lock-in. So as you start to work with one cloud vendor around their specific big data type of services, it's great. You can start to extend what you're doing, but you also end up in a situation where now you're locked into that particular vendor. So as you know, Jeffrey mentioned, as customers are moving back and forward, you can no longer move back or forward. You're stuck. You're locked in. On top of that is cost. So the cost is complex. So, you know, if you start to think about it in terms of the, you know, cost for on-premise type of solutions, you've got the hardware, you've got the systems. Understanding exactly kind of what the costs are on the cloud are a bit challenging. There are a couple of factors. First, there's clearly visible costs, and these scale dependent upon, you know, the workloads you're running. So understanding the workloads is important. Workloads that are long-running workloads might typically be more cost-efficient to run on-premise. Short-running, more ephemeral workloads or linked workloads would fit more reasonably in the cloud. You also have consideration for anytime you're moving data within the cloud. Cloud providers make it very easy to get the data in, but if you have to move the data between clouds or between applications, it can vary significantly. So, for example, for like 30 terabytes, a recent study looks at current pricing, you're talking about a minimum of around $3,000 for each time you move it, up to $6,000 depending upon what region. So this varies by region. So if you are a company that has data centers or cloud data centers in multiple geographies, it's going to cost you differently for each different move and through each different cloud. So cost in just data movement is challenging. Behind that, you have not just the visible costs, you also have the hidden costs around some of the cloud service offerings. There's API requests, there's networking bandwidth, all that you have to factor into your cost scenario, which makes it more challenging as you start to forecast, you know, what these new workloads are going to cost as you start to move to the cloud. So you need tools and ways to start to drive some visibility around your workload utilization so you can figure out how you can start to, which workloads are more appropriate for cloud. On top of the cost issue, there's one thing that never really goes away, which is data stewardship, data governance. And as I mentioned before, we still have the same challenges anytime with your data governance. Right now, data can be stored anywhere, in any cloud, in multiple clouds. Increasingly, you're seeing workloads where data is being generated in the cloud at first. So IoT type of use cases or cloud-native analytics, all of these need to have a way to manage policy, manage governance of the data that's critical to you, to be able to your internal customers, to be able to drive insight and visibility. The cost of simply trying to pull data from each of these individual silos is the same challenge we were dealing with before on-premise, but but on steroids for the cloud. Cost data breaches alone, if you start to think about what the current costs are, average cost for data breach is around $3.2 million. And that's also something that goes all the way up to the executive team in terms of their liability around these costs, so and the reputation of your company. So we may be talking about data architectures, we may be talking about how we're building application architecture to support this, but we're also impacting even more so than we have before the risk to the business. Also, GDPR. While many companies think about GDPR as something that is happening in Europe, almost more than 3/4 of the companies currently out there worldwide are going to be impacted by GDPR. Even if you're a US-only company, it's just simply a matter of time. It's good data practice to begin with. The challenge with GDPR is there's actual fines. There's actual proven cost associated with that. So that's being enforced with teeth. We've had different regulatory rules across over the years that have been enforced to some level and others not so much. So this is creating a key driver for organizations to make sure this is under governance, this is under management. So what this is meaning is that you really need to start to find a way to leverage and create a modern kind of hybrid architecture that allows you to connect all of the different data types that you're working with across both what your data centers and within the cloud to create a hybrid architecture that will allow you to extend even data collection to the edge. Obviously, IoT is a growing area. Data collection, data management to the devices is critical in terms of future growth for a lot of companies. We start looking at manufacturing operations. You start looking at how we're continuing to grow the number of devices that are out there. Being able to consolidate that data, bring that in, is all part of what needs to be defined as part of your modern hybrid data architecture. So extending both on the cloud and into the data center. We need to have a seamless way to be able to develop and manage workloads. We need to have a seamless way to move data as this evolves and be able to make the right choices and trade-offs in terms of where the workloads need to run. So what you need as a fundamental underpinnings for a modern hybrid data architecture. First, you have to be able to support data at rest and data in motion. Eric talked earlier about the proliferation of database systems, that huge growth we had in providing different tools that are out there to address different data storage needs and data management needs. Today, the need to connect these disparate different databases and data management tools is even more important and even more complex when it comes to the cloud. So a modern hybrid data architecture needs to not only connect between data motion and data at rest, it needs to make sure you're managing that, able to manage that entire life cycle all the way to the edge of the data stream. It has to have that on-premise, cloud, and multi-cloud. As we mentioned before, multi-cloud is a reality today. So how can you facilitate or make it easier for you to really own your data? When you start looking at lock-in, the more data that gets locked into a particular cloud provider, the challenge about moving that data, you basically are no longer the steward of that data. So you need to make sure that you have the tools and abilities to span and manage across that. Always focusing around how we drive more new process and insight, and with a consistent framework for security, governance, and operations. This is, as you think about the pressures as we start to look at data running in the cloud in these different applications and these different locations, maintaining policies, ensuring consistency of those policies is a key challenge and a huge cost to a lot of organizations, especially as we continue with this growing data sprawl. And of course, hybrid cloud is key to that architecture. So I'll talk a little bit about what Hortonworks is doing to help address those issues for customers. First, we're looking to make sure we are enabling hybrid cloud data and workload agility. I'll talk about that in a second. Now, one of the key value we see from that is reducing the time to value and really kind of cutting back on shadow IT. You should be able to deploy a workload in your cloud of choice. You need to have the tools to send both the governance and policy and security information with the data. We are working to ensure that with our hybrid architecture, we're enabling you to get all the data under management, regardless of where it sits, so you can drive increased insight from that. And to combat the key data silos that we were talking about before. And we're doing this all based on this modern data architecture that we're looking to extend across the data center and to the cloud. There it goes. And we're doing this through our key platform products, which are effectively hybrid by design, hybrid data in terms of connecting data at motion and data at rest, hybrid cloud, allowing to operate both on the cloud and on-premise, and support for multiple clouds that we have today. So it's not just one cloud provider. We have native integrations with the different cloud providers to make sure that we can create that consistent data fabric. We have the ability to allow you to manage governance and your security with integration with our products like DataPlane and Atlas and Ranger from a project perspective, and how that brings together a consistent governance and security platform. And then we are enabling to support a variety of different workloads, whether it be Hive, whether it be Spark workloads, the different workloads that you're looking to run. We're providing that underlying platform to enable those different database systems to share this common architecture, policy, and security. So what does that mean about what's part of a overall kind of data fabric? So there are three key components. One is a common set of shared services, and these are shared services for data movement, data governance. Right now, if you look at the tooling that you have, many times customers have 3 or 4 different kinds of tools just for data movement. Key to having an ability to have a data fabric is have these shared set of services that can be deployed and utilized across different environments, across different data sets. Connectivity between the different data that you have, so creating that framework and connectivity between individual SaaS workloads. They may be data sets that you put in the cloud. They may be on-premise data. Be able to have the ability to connect those data through a single pane of glass, and then provide application portability. So today, if you look at applications that you're writing today for the cloud, if you're writing a new cloud native using something like EMR or some of the other solutions that are offered in the cloud, you are in effect creating a locked-in application. Your application, the ability to move that application from cloud to cloud, to bring that back on premise, if you determine that the workload doesn't necessarily fit, the work you did to predict the fitness of that workload didn't turn out because you changed your business goals, you're now stuck in that cloud. You now have to rewrite that code. You have to add that cost. So the goal of a data fabric is to make sure we have application portability. So you can both move the data, you can move the applications, and you can only have to write it once. So what we're doing is making sure through our products that we're enabling that core data management platform with the uniform fabric. We're having that connectivity to the different clouds and on-premise, so you can have a single pane of glass across your data access methods and provide the tooling to enable you to get insight and manage that data altogether. We're also continuing to lead in the community in terms of how we're driving the next generation of hybrid cloud architecture. So today, as we look at the evolution of cloud and on-prem, Hadoop started focusing on the idea of converging compute and storage as a way to get value and better value out of key workloads and key projects. And those use cases still exist today. In the cloud, we have a separation of compute and storage. We have a new architecture that is there. And so today you end up with a different architecture in the cloud and a different architecture on-premise, which means there's shift and lift, there's more work to maintain consistency. Our view is that you should have a consistent architecture both on-premise and cloud. This is key to really enabling a true data fabric, because then you can have consistency around the tooling, you can have consistency around the data access, and you can have consistency around policy and governance. So what we've started is this initiative, we announced it at Strata. This is the Open Hybrid Cloud initiative. We announced this initiative with both Red Hat and IBM, and it is focused on helping to bring cloud-native technologies like containers, which we have currently on-premise with our current products, but also combine that with a separation of compute and storage like you have in the cloud. Our view is that you need to have a seamless architecture, and so we're working now within the community to start to extend and work around Kubernetes, to extend Kubernetes for big data. We've just joined the CNCF, which is the Cloud Native Compute Foundation, to collaborate with founders of the community and to start to bring the big data Hadoop community together with the cloud native architecture community to build the foundation for that underlying data fabric. So today we're working to move not just what we can enable today, but also move ahead in terms of how do we bring containerization for both workloads and applications, really the separation of that compute and storage, and start to work on new technologies in the community to bring these two communities together. So today, we've been working on delivering against these key requirements for this hybrid data architecture, which is the underpinnings for your data fabric. First, it's a cloud-native data architecture, and we've already delivering that with our current HTTP 3.0 product, which gives you, Docker containerization for your native workloads. We are now extending to the edge with our HDF product, Hortonworks Data Flow. And we introduced last year our Hortonworks Data Plane, which provides that consistent single pane of glass across your different clusters and workloads, whether they will be on-premise or in the cloud. We have customers today using both our products in cloud deployments and on-premise. We're going to continue to evolve that. And then as we start to move, the other last key requirement we think is a seamless architecture, and that's what we started to drive with this new Open Hybrid Architecture initiative. So we'll start to see more about how we're bringing those two communities together and the work we're doing with Kubernetes community to help drive this foundation for this new architecture. But fundamentally, as we look at the new data fabric, it has to incorporate, both the architectures of the cloud and bring those on-prem. We need to get the benefits of the cloud across that data architecture, and only then can we start to look at a complete next-generation view of this new data fabric. So that's where we're focused on helping make you guys successful today. So Eric, I pass it back to you.
All righty. We do have a couple of good questions from the audience, and I guess first I'll throw over to you, Scott, just for commentary, and then Jeff, feel free to chime in on this. When you were talking about the egress fees for cloud environments, I'm reminded of Hotel California, right? You can check out any time you like, but you can never leave without at least paying through the nose. Do you see that changing? I mean, that's obviously a very calculated strategy by these organizations to keep you there. It's almost strong encouragement to stay, aka lock in. But do you see that changing over time?
So I don't see it changing anytime soon. There is always the possibility for reduction in fees, but that's fundamentally the business model for storage in the cloud.
Right.
It's free to put it in. It costs to take it out. The cost for the overhead cost for storage, for just the storage itself, is relatively minimal in comparison. So data movement is going to continue to be with us. So it's going to be critical when you start looking at, as I was mentioning earlier, what is the right workload for the cloud, for your cloud use case. It's important that you're considering all those costs. So where do we need to move data, what's it going to cost us to move data in and out, and that'll help you identify what's the right workloads to put in the cloud based on the cost profile.
And there's also a technical side to that we've discovered. And so as you start building up these high volumes of data on a big data platform, you can't always get them off because you run into the real world issues that you try to move them and they're getting moved and the network has a hiccup and there goes that. We've seen bugs in some of the Hadoop stack code that goes down to the source Apache code that causes problems and that won't come across. So what we've done in certain circumstances is we've built up some routines whereby we'll get the individual pieces off onto Linux servers. We'll use the actual speed of Linux to then zip them up and recombine them. And sometimes this is actually going through an audit trail. So we then have to count the number of lines and files and things like that, and then push them back in another pathway. That all sounds great if that would never, you wouldn't have to do that, you just push a button. But some of that is the pain and suffering of actually moving large quantities of data, and that actually should go into your design planning and your design criteria.
Yeah, and I think one of the real, oh, go ahead. Yeah, go ahead, Scott.
Yeah, I'm just confirming. Yeah, absolutely. That needs to be part of your design criteria.
Yeah, and things are changing, right? One of the innovations I'm looking forward to seeing more and more is going to be visibility into these different cloud environments and the associated pricing on specific workloads, for example, on storage, on egress, and so forth. That's already starting a bit, but maybe, Jeff, I'll throw it out to you first. Have you seen much along the lines of engines or tools that can see into these different environments and then calculate the costs for you and give you some estimates? Because one of the funnier jokes I've heard is that the most ungoverned line item on your IT budget these days is your Amazon Web Services bill, because you just don't know what it's going to be. So there's a real movement afoot. Yeah, can you kind of talk about that for a second?
Yeah, I've seen some homegrown ones, and I even made one to do a design comparison. And like you said, this is all business, okay? So it's, hook the client, bring them in, take their wallet. So the issue is that with Amazon particularly, if you do the cost functioning, then if you were going to do very heavy compute on very large quantities, which would be a use case like financial audit or something like that, where you have to iteratively go through it, your costs go up exponentially. If you're doing some simple stuff, like maybe just balancing accounts, and that's all you're doing is checking this against that, then you can keep it reasonable. But you probably really do want to do that. It's nothing against the cloud suppliers whatsoever, because as it turns out, a lot of times the on-premises run as corporate centers that you then have to pay a fee to do hosting as well. So that's a common organizational approach. And then you'll actually find that one of the reasons people go to clouds is that over time, the cost footprint of that on-premise corporate center is excessively high. And so it's actually cheaper to go to the cloud. And that's just the normal dynamics, but I would say look for some information. There is some good information that gives you guidance out there Generally, they're in blogs, believe it or not. Somebody will fess up and be honest. That's almost unheard of in IT, but those people do, and they live on. They're in hiding. They're in an FBI protection program. And so, and then I would do that. But I would actually suggest doing that, particularly with the hybrid. And again, I'm extolling the hybrid approach because it gives you the flexibility to do that analysis and change.
Yep. Well, we got a good question here from an attendee. I'll throw it over to Scott for your perspective. The question is, why does the cloud require separation of compute and storage? I mean, this is a very common architecture that's being deployed these days, and I think it's largely due to the desire to lower costs, and in other words, to only charge for compute when you need it. But there are some costs associated with that, right? You lose a little bit of speed when you separate cloud and storage, right?
Well, there's certainly some cost. There are certainly some things that you do lose, and that's why it's really important to understand in terms of what are the workloads that you're looking to put up there, and what's the return you're looking to get out of those. When you think about the cloud, that separation of compute and storage was kind of built in by nature, right? That's the structure of the architecture that we were provided. So there is benefit as the data sets, grow to also be able to have the ability to scale the compute to fit that. So again, workload specific. But it does change the way people look at optimizing their infrastructure. So when you think about and this comes back to your workload planning, when you start thinking about your infrastructure, when you have an on-premise solution, you're trying to optimize for more workloads, more processes on the same infrastructure. It turns out when you go to the cloud, it's a little different. You're actually optimizing for lowest cost versus highest output. So your factor that you start looking at with that separation of compute and storage, and as you point out, there's some loss there that you start to think about that differently in terms of how you size and work toward valuing that.
Right. It all gets back to that planning that you were talking about, right, Jeff, that you really need to think through what you're doing in here and try to have a relatively long view, I suppose. But how long is that view these days? I mean, can you realistically expect to be looking 2 years down the line or a year down the line? What kind of reality?
Realistically, for a larger organization, if you went in and you were taking advantage of industry best practices, lessons learned, and there are a series of experts that are available, and you have to realize that it's multifaceted. So there's a bunch of experts out there, solo and in consulting companies, that'll come in and kind of give you a top-down view of the world. And that's a wonderful thing, but that will completely ignore the reality of the challenges that you're looking at in the slide that Eric is showing, because that's not their area of expertise. They don't know from experience that, I'll throw one out here because this is a technical thing. Oozie has a deeply embedded bug in it whereby if the time of the servers is off just by a short amount, not even the large amount that is common, it actually executes a negative time and it crashes. And the only way you find that out is looking through 300 megabytes of Oozie logs, which are distributed all over the place. And so that's a real-world challenge. And then there's other ones where Hugh stops downloading the file because it just felt like it. It's like a child, like a teenager. I'm done. You've asked me to do too much homework, and I'm done. I'm going out with my friends. Leave me alone. And you get over that, and you can work around those, but then those are going to drive you into what you do. But they also, because cost functions, in terms of have you place that functionality where you really have the expert staff that can solve that in 15 minutes, or are they going to be scratching their heads for 2 weeks? So you have to do that, and I would say take advantage. It's well worth your time, but recognize it's not going to be one set of internal or external consultants. You're actually going to need that. It's called red teaming, if people are familiar with it. You get very hard-nosed, socially inept people to give you the truth bluntly, and that's what you really want.
That's funny. And you guys, I mean, at Hortonworks, you've been focused now for, the past decade or so, including the build-up time before you formally launched, at surveying these open source projects and then choosing which ones make sense in your overall portfolio. And it's really starting to crystallize these days. So you talk about this connected data platform, basically, and that is a very forward-looking architecture, right, where you're trying to accommodate both for data at rest and data in motion, which are very different environments, very different technologies involved, at least in certain senses. Can you just talk a bit about how that works and how Hortonworks operates, how it actually makes, how data works with Hortonworks?
Yeah, I think that the way that you point out is capturing both data in motion and data at rest, obviously with our HDP product, and which is obviously we're focused around HDFS and the workloads on top of that and the governance and management of that. Our Hortonworks Data Flow product really focuses on bringing data in from the endpoints, from IoT devices, being able to manage, be able to pull that data in while at the same time doing analytics on that data, either at the point where it's captured or in flight. And so what we see is our data plane product really kind of connecting that common single pane of glass across these different sets of technologies designed both from an analytics perspective and then designed from a data flow or data management perspective to be able to give that direct insight. So for us, connecting the different data products and the different analytics workloads is key to getting that insight.
Yep. And we had another good question here from an attendee. Are there any tools that would let you track data you inadvertently might have left behind in the cloud? We are certainly seeing a rise in what are called data catalogs, which I think are very useful technologies for, and depending upon how they work, but one of the really valuable bits of functionality that I've come across is just the ability to crawl across your environments and find data that's sitting out there. And of course, they rely largely on metadata to be able to piece together what's actually out there. But it's an interesting question, certainly for GDPR, right? You had mentioned, Scott, that GDPR, even though it's a EU set of regulations that have come out, nonetheless it does affect the U.S., and it's also a straw in the wind, it seems to me. So you do want to have some capability to literally to canvas and know what's actually out there. Can you talk a bit about how Hortonworks tackles that challenge?
Yeah, again, that's another area that we tackle through our cataloging capabilities. The key there is the metadata component and what we're doing to make sure there's shared metadata, especially in these hybrid environments. So when you start looking at the hybrid architectures and data fabrics, it's not just good enough to have the metadata that's within your on-premise. It needs to extend to that hybrid cloud environment. So when we talk about shared services is metadata is one component of the shared services architecture, so that we can do that data cataloging and the data lineage tracking for both whether it's on-premise or in the cloud. For just these reasons is GDPR.
Yep. Yeah, and I guess final thoughts from you, Jeff, on the importance of taking this opportunity as hybrid cloud and multi-cloud become the norm, and it seems to me that multi-cloud is going to be the de facto norm going forward. This is an opportunity to take a hard look at your data management practices, your policies, your technology stack, and maybe try to slowly but surely winnow some of those legacy applications and legacy tools to focus more on a shared services model, as Scott is suggesting. Well, what do you think about that?
Yes, and I agree totally with that. And I would say one of the lessons learned that would be valuable to take to heart is don't try to do it all. And also recognize that there's a reason why silos keep occurring, because that's the natural state of large organizations. It breaks it down into zones of authority, zones of control, zones of promotion, zones of it's mine, leave me alone. So you want to take that to heart and always solve an important problem that is solvable and do that up front. Get the political capital. Don't try to solve it all. Don't drag it down by the super hard problem. Number two, do that as quickly as is possible. So drive out all the hurdles for time, which means, and for goodness sake, it's 2018. Let's not have a committee of 50 people from 20 different organizations where you require consensus. I mean, my goodness, we would have like dangerous to eat tuna salad if that was the way we did picnic. So let's get a small committee, let's have it have real authority, solve one problem, accept some risk. Get people on the committee who are willing to say, you know what, this might fail, but I'm willing to go for it, and get some real success there.
I love it. Any closing comments from you, Scott? Where can people go for more information?
Yeah, obviously, you can go to our website for more information. We've worked our professional services team, and we've worked obviously with customers to help them work through this journey and start to do some of the things that we've been talking about today. So we can certainly help you, guide you on some of that as well. And then obviously our resources that we have online are great ways to start to get aware of what the next steps are.
Yep. Great stuff, folks. We learned a lot about how data works today. Big thanks to our friends at HortonWorks and Scott Clinton, and of course big thanks to our own resident actual data scientist, Dr. Jeffrey Malofsky. We do archive all these webinars for later viewing. Hop online to Insight Analysis soon. It should be up probably by tomorrow. And with that, we're going to bid you farewell, folks. If you have any specific thing you'd like to learn from some of these events, don't be shy. Send me an email, info@insightanalysis.com. It will come right to me. Thanks again for your time and attention. I just love learning about how data works. We'll talk to you next time, folks. Take care. Bye-bye.